Today we're going to talk about how to solve systems of equations by substitution. In this first example, there's two things that I want to point out to you. The first is that both of these are lines. How do I know that both of these are lines? Because if I look at the x term, in both equations, the x term is raised to the first power. That makes it a linear term. There are three possibilities when you have two lines. Possibility number one is that these two lines will cross in exactly one location. When they cross, the place that they cross is going to be a point. So if the lines cross, they have one solution. Possibility number two, these two lines could run side by side, having the same slope. And in this case, they won't ever cross. These are parallel lines. If they never cross, they have no solution. Possibility number three is that if I rewrite or rearrange these lines or plug them into each other, I find out that they are actually the same line. In this case, they are crossing or sharing every single point. And when they share all their points, they have infinite solutions. So in number one, the first step typically in substitution is to take one of your equations and solve it for a variable. You'll notice that both of these are already solved for y, meaning that y is all by itself. So we can go ahead and make the substitution. I could take the second equation, and since y is equal to x plus 2, I could take this value and substitute it for y in the first equation. That would give me x plus 2 equals 6x plus 22. Now I have an equation that only has one variable. So we want to solve for x. We need to start by getting our x's on the same side. So I'm going to subtract 6x and bring it to the left-hand side. That gives me negative 5x plus 2 equal to 22. Again, since we're solving for x, I need to get rid of both the negative 5 and the positive 2. We'll do our addition or subtraction first, and then our multiplication or division second. So I'll start by subtracting 2. Negative 5x is equal to 20. Final step. Since negative 5 is multiplied times 5, I do the opposite operation to get rid of it. I'll divide by negative 5. So x is equal to negative 4. Now, like I said before, when two lines cross, they cross at a point. So when I'm writing the answer for this system, I'm going to write it as a point. I know the x value, but I do not know the y value. I can find the y value by taking my x and I can plug it into either equation. I typically pick the one that I think will be the easiest. So I'm going to pick equation number 2. If I put in negative 4 where the x is, I'll be adding negative 4 plus 2, which gives me negative 2. So these two lines cross at the point negative 4, negative 2. In example 2, you can see that we don't have an equation that has been solved for a variable. There's a way to look for an easy solve. Things that I typically look for is a variable that doesn't have a coefficient, and if I can pick one that's also positive, that will be the easiest one to solve for. So I'm going to solve for x in the second equation. I can do this in one step. To get x completely by itself, I'll subtract 9y. So now I have x equals negative 11 minus 9y. I can't combine these two terms because they are not alike. One of them has a y and the other one doesn't. So since I solved equation 2 for x, I will take my answer and I'm going to plug it in for x in equation 1. Make sure that you use parentheses around the variable that you're plugging into. So I've got negative parentheses plus 2y equals 0. So what goes in the parentheses? My answer. X is equal to negative 11 minus 9y. Now I used parentheses because there was a negative sign in front of the x. This negative is going to apply to both terms inside of the parentheses. So it will become positive 11 and positive 9y. Now that I've distributed my negative sign, I can combine the like terms. 9y and 2y is 11y. Now I can solve for y. I'll start by subtracting 11. That gives me 11y equal to negative 11, and then I'll divide by 11. So y is equal to negative 1. Now just like before, the solution is a point, and I only have half of this point. I know that y is negative 1. I need to find out what x is. I have 3 options. I can plug it into the first equation, the second equation, or I have created a third equation. This is where I'm going to plug this answer. X is equal to negative 11 minus 9 times negative 1. So negative 11 plus 9 gives me a negative 2. In number 3, I'm going to solve for the variable again. And I'm looking at my options, and I believe that the x in equation number 1 will be the easiest to solve for. I can do that in one step. I will add 4y to both sides. That will result in x equal to 4y. Since I solved equation 1 for x, I will plug into equation 2 for x. Use parentheses. So I have 2 times 4y minus 8y equals 1. I'll distribute. 2 times 4y is 8y minus 8y equals 1. The 8y's cancel each other out, leaving 0 equal to 1. Well, that doesn't make any sense. 0 does not equal 1. When your variables go away and you're left with an answer that does not make any sense, this is a no solution. No solution occurs when you have parallel lines. So we can stop here and we'll write this as our answer. Number 4 is just an example with fractions. There's nothing special about it other than the fact that I wanted you to realize that fractions follow exactly the same steps. Step number 1 is going to be to look for that variable that would be easy to solve for. In this case, it would be the y in equation 2. I can solve for this y by subtracting 1/4 x on both sides of this equation. That leaves me with y equal to 10 minus 1/4 x. Now, since I solved equation 2 for y, I'm going to plug into equation 1 for y. Use parentheses. I've got 1/2 x plus 1/3 parentheses equal to 5. So what goes in the parentheses? 10 minus 1/4 x. Now we're going to need to distribute 1/3 to each of the terms in the parentheses. If you're multiplying a fraction times a whole number, just put the whole number over 1. So I get 1/2 x plus 10/3 minus 1/12 x equal to 5. So just like before, now that we have an equation that's all in one variable, let's look to see if there are things that can be combined. In this case, I can put the 1/2 and the -1/12 together. Now remember, you're going to need to get a common denominator. In this case, your common denominator would be 12. 2 will go into 12 6 times. 6 times 1 is 6. Then you can do your subtraction. 6/12 minus 1/12 is 5/12. Don't forget to put your x on it. Now, to solve for x, we'll start by subtracting 10/3. Again, in order to do this, we're going to need to get a common denominator. I have 5/1 minus 10/3. My common denominator would be 3. 1 will go into 3 times, and 3 times 5 is 15. 15/3 minus 10/3 is 5/3. Now for our final step, normally if something is multiplied, we would divide it on both sides, but you cannot divide a fraction. Instead, you must multiply by the reciprocal, 12/5. When you do this on the left, you get 60 divided by 60, which is just 1. And on the right, look for things that can cancel. You're allowed to cancel diagonally, and you can cancel top to bottom, but you cannot cancel side to side because that's how you multiply. So I can cancel the 5, and 3 will go into 12 4 times. So that leaves me with 4 for my x value. I'm almost done. Again, remember this is a point, and I only have the x part of it. I need the y. What should I do? Take my x value, and I'll plug it into one of these equations. You have 3 options, but I think option number 3 is going to be our easiest. If I do 10 minus 1/4 times 4, I get 10 minus 1. 10 minus 1 is 9, and so the point where these two lines cross is 4, 9. In number 5, there isn't an easy variable to solve for. All of them have a coefficient, and so I have to just choose one. It really doesn't matter which one you choose. I'm going to choose x in the second equation. In order to solve for x in this second equation, I'll start by adding 7y. So I get 6x equals -15 plus 7y. Now I need to divide by 6. Remember, you're going to divide every single term by 6. If you have fractions, do not write them as mixed numbers, but do simplify them. So -15/6 will become -5/2. So now that I've solved equation 2 for x, I will plug my answer into equation 1 for x. Make sure you use parentheses. -12, parentheses, and then I have plus 14y equal to 30. So I'll put all of this into my parentheses. -5/2 plus 7/6y. Now I'm going to distribute. When I multiply -12 times -5/2, be careful with your signs. It does become positive, and you get 60 divided by 2, which is 30. -12 times 7/6 is going to give me a -14y. Now I don't have any parentheses, and I can combine like terms. -14y and positive 14y cancel each other out, and that leaves me with 30 equal to 30. All right, so here's another example where the variables went away, but this equation makes sense. In this case, these are same lines, and we have infinite solutions. Number 6, Hopefully when you look at this, you notice that there is something different about these equations. The second equation is still linear, but you might notice that both of these variables are squared. This first equation is the equation for a circle. Now there's a couple options here. If I have a circle and a line, the line could cross the circle twice, creating two answers. It's also possible that the line could run next to the circle and only touch in one location. And it is possible that the line doesn't cross at all. So I could have two solutions, one solution, or no solutions. As far as solving, we're going to use the same method. We're going to pick an equation and we're going to look for something that looks relatively easy to solve for. In this case, it would be the y in the second equation. I can solve by subtracting 10x on both sides. That gives me y equal to negative 10x. Now I'm going to take this answer. Since I solved the second equation for y, I will plug it into the first equation for y. Make sure you use parentheses. So I've got x squared plus negative 10x squared equals 101. When I square negative 10x, I get 100x squared. Now I can combine like terms. 1 plus 100 is 101x squared. To solve for x squared, I'll divide by 101. And I get x squared equals 1. Now I don't want x squared, I just want x. So we use the opposite operation, which is to square root on both sides. But you got to remember, if you put a square root into the problem, you have to put a plus or minus in front of the answer side. So x is equal to both positive 1 and negative 1, which means we're going to have 2 points. X equals 1, x equals negative 1. So to get my y's, I'll have to plug in each value and see what the answer is. When I put positive 1 for x, I get negative 10. And when I put negative 1 in for x, I get positive 10.